Hi everyone. Can you hear me? Well, yeah. Can you hear me well? Or okay. Okay. So that talk is going to is about Coursier, which is a library to manage dependencies from Maven and Ivy repositories. And in particular, in this talk, I'll also discuss new things related to data engineering and also ways to distribute applications with it. So in a bit more detail, first I'll quickly describe what Coursier is currently. Then I'll discuss all this new stuff, and lastly I'll discuss more general stuff about the development of Coursier. So yeah, about me. So I'm the author of Coursier and also of Jupyter Scala, which is a Scala kernel for Jupyter. It's one of the Scala kernel for it. There are others, and also I contributed a bit to Shapeless, and currently I'm working at a company called Tids.tv at their Paris R&D office, and it's a company doing native video advertising. So first, a quick reminder about what is Coursier. So at its very core, it's a library to manage dependencies from Maven and Ivy repositories. And compared to the alternatives in Java, say, it's written in a let's say idiomatic Scala with a bit of Scala-Z in it. It tries to enforce a strict separation of concerns between, on the one hand, the resolution, that is the working of the dependency graph, say, on the one hand, and on the other hand, all the caching stuff, that is all that's related to downloading things, managing time to lives of things we downloaded. All these stuffs are clearly separated. And one of the features of Coursier is it tries to follow a hybrid model between what Maven and Ivy do. And that allows to use it in a straightforward way from SBT. That is there's very little thing to adapt to go from the way SBT sees things to the way Coursier sees them. One important component of it is its launcher. So Coursier ships with a small 12 kilobyte jar. So that's the Coursier command we see here, and so it's only 12 kilobytes because it downloads then itself in the second time the full class path of Coursier, which is progaded, so it's something like 1 or 2 megabytes. But and this launcher has a command called launch here, and with it we can launch applications from their Maven coordinates. That is here, for example, we launch the dependency Comly Ammonite some version. And what this does is this fetches the jar of this dependency along with all the jars of its transitive dependencies. This puts them in the class path. This looks for the main class of this particular dependency, and this launches that. And so I'm going to show you just to illustrate. Okay. Can you see? Yeah, okay. So if I type it, so here I think here my cache already has Ammonite, so that touches it straight away. And I'm going to show you what that gives if the cache is empty. So I'm going to start with this directory which does not exist. So here we're going to use a new cache. And if the internet is fast, this is fast, yeah. So yeah, first it downloaded the metadata files of Ammonite and its dependencies, and then it downloads the jars of all these dependencies. And when it's done, it will just launch them. okay, so the cool stuff is we have some feedback about what goes on. So here we can see we download at something like a few tens kilobytes per second. So, yeah, I don't know if I'm going to wait on for this, but once it downloaded all of these, it just launches Ammonite, and that's it, as I showed you just before. Okay, and about so this general concept, I mean, of launching applications from their coordinates, this draws some inspiration from a tool called Conscript, which is I mean, it's already a few years old, and it's something that does roughly the same things, but using more stuff from SBT. And I mean, you can Google for it, and compared to it, coursier is a bit more user-friendly in the sense that it gives more feedback about what is being downloaded when it launches things. Also, there are a bit different concepts in coursier versus Conscript. As for now, in coursier, we launch things from Maven coordinates rather than simple app names. I mean, GitHub repositories, as the Conscript does. And a last important component of coursier is its SBT plugin. So to use it, we can just throw it into the class path this way. So we add this plugin in project/plugins, and so if we have a bunch of other plugins along with it, and we want them to be downloaded by coursier, we can also add coursier in the parent project of our project. That is, we put it in project/plugins.sbt, and coursier gets downloaded for this parent project, and so it is enabled for the plugins that are simply in project/plugins, and coursier fetches all the plugins this way. Yeah, there are a few. There are a few limitations with it. So one of them is it doesn't download SBT itself. So you know when you launch SBT for the first time on a machine, or when you bump the SBT version, a bunch of I mean the class path of SBT is being downloaded, and this is not handled by coursier itself. And also the SBT coursier, the plugin, is not loaded when it is being downloaded, so it can't. I mean, it has to be downloaded first by SBT before being used. But there are going to be ways to circumvent that I'm going to show you just after. So okay, so now for the new stuff that you can do with on top of all of that. So something that is fresh new is SBT shading. So it's quite new, so not rush on it, but it's a different plugin than SBT coursier, and it allows to shed dependencies. So it's in coursier as this deals with dependency trees that coursier already handles, and it can be used basically this way. So we add the plugin to our build first. That's the first line, and then here we have a model that has two dependencies. So that's B and C. I mean org B something, org C something, and we want to shed the first one, B. And so what the plugin does is it looks at the dependency tree of our module. So here it looks like this on the right. So we have C that depends on command, and then B that depends on A that itself depends on command. And what the plugin does is it looks for all the dependencies that are brought only by shaded dependencies. So here B is shaded, A is brought only by B, which is shaded, and so B and A are going to be shaded. And to get the final jar, with B and A shaded, we can just call sbt-shading :publish, which publish our module, but using the jar built by the sbt-shading plugin. So it's quite new. The goal is to use it in Coursier, which just started to use it. So it uses it to shed unstable dependencies, and yet this plugin has a few limitations. In particular, it does quite awful things, I think, with SBT configurations, like when we call SBT, when we call shading publish here, this happens in a new SBT configuration called shading, and this configuration closely mimics what the compiled configuration of SBT does. And I mean, it's almost like config, but for a few tasks that shading wants to handle, to generate the jar with shaded dependencies, for example. And these particular things, having a configuration doing things similar to another one, turned out to be quite complicated to do. I mean, it's not the first. SBT shading is not the first plugin to try to do that. Like I know the SBT plugin of Scala debugging that that is going to be talked about tomorrow. Does similar things, and so a problem is this is not reassuring about the stability of the plugin. Like because of that, it can possibly conflict with other SBT plugin that put things in compile that could not land in a shading because of the awful things this does. So this has to be used with some caution. So another new thing. So now to launch applications is so I showed you just before how to launch applications with from Maven coordinates. That's the last line on the slide, and this is a bit cumbersome in the sense that we have to write the full coordinates with an organization, with a version, with sometimes a prefix for the Scala version, and there are actually more straightforward way to do that. Using, I mean, it would be more straightforward to use directly the application name. So here Ammonite, and being able to just launch that. And in particular, I mean, the Scala Index that the Scala Center manages knows the correspondence between application name, so here Ammonite, and full Maven coordinates. So here the thing we see at the bottom of the slide, and so this is in a PR. This is not in the current master of Coursier, but the idea here is to allow to launch applications just from their name, and having the Scala Index provide the Maven coordinates of the application to then launch that. This is a bit new. I guess is something like a hackathon way to work properly, and at the end that allows to launch application in a very straightforward way, just from the name. Another thing which is quite new. So this one is in the master of Coursier, and but it's quite uncommitted for now. So I showed you before how to launch applications with Coursier, having Coursier gather all the jars of the application that is being launched. It turns out we can do the same with Spark applications. So, for example, here, so we have a job whose Maven coordinates are com.foo something, and so what you do? So what happens here is so this is a Spark application. So when its main method creates a Spark session and then does Spark calculations, And so we like to launch that as a Spark application. And so the coursier Spark Summit allows to do that. And so as it's a Spark application, we can pass it, we can specify the number of machines we want it to run on. We can tell how much memory we want each of them to have, etc. These are the options that we pass to the Spark Summit tool. And then so basically coursier Spark Summit can be called this way. So we have first how to get the job class path. So this is it comes from these coordinates. The R option specifies an extra repository to get things from. Then we have the standard Spark Summit options that are the same that we pass to the Spark Summit script from Spark distributions, which say how much machine we want, etc. And lastly, we have the options we want to pass to our job. And so I'm going to describe in a bit more detail what goes on here. So we want to launch a Spark application, and the standard way consists, in creating assemblies and adding Spark as a provided dependency. And so with coursier Spark Summit, we don't need to do that. So we just call sbt-publish, and this publishes the job on some repositories. I'm going to talk about the yarn case, here we can assume the yarn cluster configuration is in the directory etc adobe conf, so that allows to have Spark connect to that cluster and launch things on it. And the nice thing with coursier Spark Summit is we don't need a Spark distribution like the coursier Spark Summit command, and what this command does is it fetches the job class path, and then it looks at the Spark version this job depends on, and from this version it is able to get the Spark Summit application class path. That is, when you get a standard Spark distribution, the Spark Summit script in it launches a Java application whose jars are actually on repositories, and so and coursier is able to get those on its own. So basically what this does is this allows to launch Spark applications without having to manage assemblies, without having to use these provided dependencies, without having to manage Spark distributions. This works just straight away without particularly heavy setup beforehand. Yet this is something that is quite new. From what I know, for now, from what I know, my company is the only user of it, as I was there to set it up. And so for now, we only run it on yarn clusters, and any feedback on? I think it would need a bit more. It may need some tweaking to work on standalone clusters or Mesos clusters. But any feedback is welcome if people are interested to use it on other kinds of clusters. And a last thing that is also quite new in coursier is it now has a SBT launcher. The thing with SBT is it cannot be launched. It can be launched by simply calling a main method on some classes, like coursier launch does. That is, SBT, when it is launched, requires to be passed a few implementations of things that are defined in the launcher interface module of SBT. And so that's what I mean. Coursier now has for a few weeks implementations of this, and is able to launch SBT. Yeah, okay. There's a small glitch here, but so there's now in the course the master of Coursier a small launcher called CSBT, which is able to just launch SBT. Like I can show you just after, but it proposes to do a few new things, like you know, when you have a SBT project, you set in the project / build.properties file the version of SBT. You say SBT version equals 0.13. something, and what the Coursier launcher does is it offers to read more stuff from that file. That is, for example, so this is the project / build.properties file of Coursier, and what the Coursier launcher offers is to load plugins at the same time as SBT. That is, when the launcher fetches the class path of the right version of SBT, it can also fetch a bunch of plugins which are there. It can also fetch a few dependencies. Some plugins are used via dependencies. And all of this is just some Hocon. That is, this is parsed with typesaf config, so we can use variables like for the first dependencies, which references the SBT version. Also, the Coursier SBT launcher proposes to read, to give the precedence to a file called sbt.properties instead of project / build.properties for reasons I'm going to show you. Because the thing is with this launcher, as we can fetch things at the same time that we launch SBT, we don't need to have parent project under project. You know that loads plugins, and I mean, via it, what we can do is simply scrap all that in the .sbt or .iv2 cache, and even what's under project. I mean, we can put all that we need in the sbt.properties file, and that's it. I mean, it will launch the right version of SBT, it will load plugins. And so in a way, via it, we don't need meta builds. That is the recursive builds that we find under projects. There are also some under the .sbt in the home directory. And I mean, this is all quite experimental, this is quite new, and this awaits feedback. But that's what this launcher proposes. I mean, it proposes to do without meta builds. So Coursier can be built with it, yet there are a few issues to address first. One of them is, so it's faster when we have nothing in cache compared to the standard way of launching SBT. Yet, when the cache is full, starting SBT is slower. I mean, and it feels slower when we launch it, and the problem does not come from the Coursier resolutions themselves. I mean, I don't know the exact origin of it. I mean, this has to be debugged a bit, but that's the first problem. And another problem is it seems to mess with concurrent compilations. Like, for example, if I use the new launcher and I launch test compile and just checked out Coursier sources, I typically run into weird issues like this one, which is which we don't know what to do when we face it. I mean, if you look at the details, I mean, it's the def copy, the raw default method, are actually a compiler generated method. So that's an error at the level of compiler generated method. I mean, yeah. But this compiles fine with the standard SBT, so it's there are a few things to address in the current SBT launcher of coursier. So, and any help would be welcome to make that work. Because the gain at the end is that makes for a much more user-friendly experience for newcomers when we launch SBT on a new machine. Like everything gets downloaded faster with more feedback in the console. And now for the wishes, so these are things that are not implemented in coursier, but the next thing that now that it has a SBT launcher is it would be cool to be able to launch intellij itself via coursier. Instead of having to install intellij via native installers and having to reinstall it, to update it, etc. I mean, at the end, intellij should be just a bunch of jars, and it would be cool to be able to launch it straight away this way. Yet I don't know if it's easy to do. I mean, I don't know the very details of how intellij gets launched, and but here to any help or any hint about that would be welcome. It would be very cool to be able to do that. I mean, because it's, in my opinion, it's quite a pain to install intellij on new machines. Also, yeah, and another thing is, so that's a wish too. I mean, like when you submit new Spark applications, so I showed you via coursier Spark Submit, but also when we do Spark calculations in a notebook, say, when we create a Spark session, a lot of jars get moved around. Like all the jars of Spark and the jars of the dependencies you add get sent to all the executors, for example. And I know, for example, for the jobs I manage or the notebook I use, at times it can be 1 full minute to start to simply submit the jars that the job or the notebook uses to all the executors, which is quite inefficient in the sense that basically this is almost all the time the same jars that are moved around. And so there are ways in Spark to go around that, via the local scheme when we pass jars to Spark, but this requires some extra setup. And in my opinion, a better way to do that would be, instead of shipping jars, Spark should just ship Maven coordinates, and each container that run a Spark executor, for example, could reuse things from its local cache rather than expecting jars to be sent to him by the user. And that would allow to scrap that big minute at the beginning of jobs or in notebook sessions. Yet I think that will require some changes in the Spark, the yarn code of Spark, but that code is not that big, and I think it would be worth doing. And one last thing is, this is not done yet, and here too feedback would be welcome about that. A command that could be added to coursier would be something like coursier install. Like, for example, if you want to install Scala format or Ammonite or SBT, say, you could just run coursier install that command, and that would put a small launcher in somewhere in the path of the user. So it can be in a USR local bin. So it would put a launcher there to launch each of these applications. And we can imagine having a coursier update command to ensure that all the launchers launch the latest versions of all the installed applications. This is not done yet, so for now one has to use coursier launch something, but I, I think it would be nice to have to launch Scala applications. The bootstrap command you have to install yourself. You know you have to put the bootstrap in the path yourself. I guess that could be just a shortcut to put bootstrap in the path, but maybe it could not be bootstraps, because bootstraps download their own jars and they put them in special directories. And I mean, this one could use things that are, under .coursier slash cache, etc. I mean, there are no details here. I mean, but yeah, that would be a bit like a bootstrap today. Yeah, that's it. And now, yeah, just a few considerations about the project. As coursier grew a bit, there are a few things that became a bit hard to manage. Like, for example, it now consists in a lot of modules, and there are now like something like 6 or 7 reasons why the CI fails. Like it now does 3 Scala versions, and sometimes you forget that things don't compile in Scala 2.10, and you get errors. Then it has 2 SBT plugins with a scripted test, and which are as extra reasons to have the compilation fail. It's also cross-compiled to Scala.js, which is yet another reason to have things that don't work, like some method from Java that are not implemented yet in Scala.js. Plus, there are a bunch of other reasons, like it has a Windows CI, so sometimes things fail on Windows. It has integration tests with external components that have to be updated. Then, if all the test paths, sometimes there are binary compatibility issues. And then, if all of this is fine, there are modules of coursier that are tested against Java 6. And I mean, all in all, that made the project a bit hard to evolve, and that's one aspect that would have to be to be worked around, I think, in the future. Another thing is in the short term, I guess the effort, I mean, at least my effort will be focused on lowering the barrier to contributing to it, like by having a better look and writing a more detailed contributing document. To at the end lower the truck factor, say, of coursier, and so that's it. If you have questions or the Bootstrap is actually a small Java application. The question was how the coursier Bootstrap command works, and so it works. The coursier Bootstrap command generates small launchers of 12 kilobytes, something like this, and this launcher is actually a Java application that looks in its class path for a resource file called I don't even remember the name, but it looks for a file in the jar, a resource file in the jar, which lists the URLs it has to download to launch the application. And so upon first launch, it looks for these URLs. It looks if it has not already downloaded them, and if it hasn't, it downloaded them and then just launches it. So it's a small Java application. Okay. Okay. So another question. Okay. Thanks. Thanks for your attention.